Uh, Thank you. I'm Hyun Jo from Department of the Ocean Marine Science. It should be noted that this research is still in its early stage, so there is no definitive result yet. The content is, despite of global warming, the southern hemisphere are showing decreasing or insignificant change in water temperature compared to other ocean basin. The main reason for this is due to overlaying system driven by intensified westerly winds and which enhance the climatological overturning circulation. On the other hand, recent studies have shown that freshwater flux driven by sea ice melting could modulate the heat uptake and heat storage in the Southern Ocean. In this study, I will plan to research how the sea ice near the Western Antarctic affect heat uptake and heat storage change in the South Pacific. To reduce uncertainties of high latitude values, I used four reanalysis data and two model data and four in-situ data to analysis and validations. This figure above shows surface and deep layer cooling of southern oceans and heat storage capability. Generally, heat in the atmosphere absorbed in the latitude higher than 60 degree and stored at 15 degree of the south latitude. Meanwhile, the ice plays an important role in the surface ocean by reducing reflection rate, which is called albedo, and produces fresh water. Interestingly, sea ice of the Antarctic sharply decreased in 2015, and there would be change in heat uptake capability and heat storage in southern oceans. The vertical sections below showed increasing in salinity and sublayer cooling, which may result more heat flow in the sublayers. My presentation is here finished, and thank you for listening.
Hi, I'm Hyun Ju. My title is Wave Attenuation by Inclined Porous Plates using Dual Boundary Element Method. In this research, I wanted to know which type of inclined porous plate has effective wave absorbing performance. I used double boundary element method DBEM for mathematical method and conducted experiment. There are three types in figure 1. As you can see, A is single plate and B and C are double plates with different shape. To use linear potential theory, I assume that the fluid is ideal, small wave height, and the velocity potential satisfy the Laplace equation and linearized boundary conditions. And then I got unique solutions after solving hypersingular boundary integral equation. These equations come from the DBEM. I also conducted experiments to validate the solutions. There is a tank with wave maker and porous plate at the back. And there are three wave gauges in the middle of the tank to get the reflection coefficient. Better wave absorbing performances, a smaller reflection coefficient will be gained. The solution showed good agreement with experiment, and double porous plates don't have meaningful contribution to energy dissipation. I found that single inclined porous plate of 0.1 porosity is effective to absorb waves. Thank you.
Evening, everyone. Myself is Swapnil Patil, and today I'm going to present my poster presentation. This, uh, this is the title of in Unraveling the Electrocatalytic Properties of Non-Noble Metal-Based NiCoW composite with MXene, intercomposite towards trifunctional activity, hydrogen, oxygen, and methanol oxidation reaction. In this modern era, green hydrogen generated from electrochemical water splitting garnered significant attention due to zero emissions. That's why uh, we are approaching low cost electrocatalyst for hydrogen evaluation, oxygen evaluation, and methanol oxidation reaction we are using. This is the schematic diagram of the proposed work, and this is the physiochemical characterization of the our material. This is the PCM, TM, and TM and XBase analysis. In figure 3A, figure 1A, this is the LSV Tapel slope and EIS analysis of the hydrogen evaluation reaction. In figure 2, electrochemical performance of the oxygen evaluation reaction. This is the LSV Tapel slope and EIS analysis. Then we go the methanol oxidation reaction from various concentration of methanol we optimized here, and this is the CV cyclic voltammetry, and this is the uh, bar chart showing the concentration of the methanol bare electrode to 2.5 methanol concentration, and this is the various concentration if we are adding, then our device results showing less percentage in cyclic voltammetry. And later we did this is the two electrode data device, and this is the we did stability, and after that we did here first time, this is the time series analysis we did here. This is the experimental and predicted potential of the cell are good agreement with each other, suggesting the time series analysis can model and predict the complex data of the our material. Additionally, owing to the synergetic effect of trimetallic, NiCoW, and two-dimensional MXene, methanol oxidation reaction properties of the trimetallic NiCoW with MXene were extensively investigated in alkaline medium with various methanol concentration. This comprehensive study provides insight into passive fabrication of efficient transition and MXene based heterostructure catalysis for the next generation energy conversion technologies. Thank you.
My study is real-time spatial coordinate tracking system of focused ultrasound with MATLAB. The objective of this study is to develop a real-time tracking system for guidance of focused ultrasound focal point using MATLAB software. Real-time monitoring of focused ultrasound focal point is critical for clinical treatment, but there are currently limited tools available in the laboratory. This study offers an open source MATLAB framework for researchers. Instead of using animal models like those in previous studies, this study employs an artificial phantom shaped like a porcine skull, which reconstructed from actual CT images. Porcine skull is anatomically similar to the human skull in terms of thickness and brain shape. Initially, an open source toolkit program was used to load the real-time position data from the optical tracker. This toolkit can acquire position data from the optical tracker, and the MATLAB application is designed to work with any STL files, not limited to the pig skull, and it visualizes the real-time focused ultrasound focal point in XYZ coordinates. The system developed in this study was built using existing open source resources, making it easy for individuals to add new features or customize it. And future research will focus on various features such as the cross-sectional view of CT images regarding transducer placement, real-time targeting error measurement, and compatibility tests with human CT data or based on this framework? Thanks for your listening.
Okay.
I'm Daehan, and my study is effects of large-scale wildfire on aerosols and cloud condensation nuclei in South Korea. This study analyzed the characteristics of changes in air pollutants and cloud condensation nuclei induced by a large-scale wildfire in Ulsan, South Korea from 4 to 13 March 2022 using community multi-scale air quality modeling system with brute force method to analyze the impact of biomass burning emissions on air quality. We used fin emissions inventory provided by NCAR. The mean contributions of BB emissions to aerosols reached approximately 13%, 90%, and 29% respectively within the mean influence area of wildfires. This shows in figure 2. As a result, the largest contributions of BB emissions to air pollutant concentrations and CCN number concentrations were predicted at nearby Ulsan areas that closest to the fire hotspot. In conclusion, it is estimated that the increase in CCN number concentration due to BB emissions may cause an increase in condensation nuclei and numerical growth and may have some influence on the development of precipitation. My presentation is done. Thank you.
Thank you. Good afternoon. I am Senthil Kumar. This poster presentation is focusing on cost-effective optimization of an array of wave energy converters placed in front of a vertical seawall. Wave energy has higher power density compared to solar and wind energy, but it has not yet achieved commercial viability because its levelized cost of energy is still lacking competitiveness with other renewable sources. Hence, achieving cost effectiveness in harnessing wave energy is essential to make it commercially viable option. So this study focused on placing an array of wave energy converters in front of a vertical seawall to make use of standing waves and hydrodynamic interactions among them with a different parameters such as diameter, number of converters, and spacing between them. And also a cost indicator is used to rank the cost-effective configuration, which is a ratio of submerged volume to extracted power, which reflects the cost associated with extracting a unit of electrical power. So through this parametric study, it was found that the converters placed in front of the vertical seawall with a larger number of converters in an array while keeping a shorter distance between them achieve higher power extraction and cost effectiveness. Because the formation of standing waves due to total reflection by vertical seawall and trapped waves among converters increases the heave motion of each converter. So this increased motion leads to higher power extraction. So in this study, two power takeoff damping methods are considered: an optimal PTO damping at natural frequency and PTO damping that result in maximum power output. The larger diameter converters rank best at optimal PTO damping, and smaller diameter rank best in maximum PTO damping for an equivalent submerged volume of converters. Thank you.